Hello, I am Dr. Urijit Shah, Associate Professor of BP Poddar Institute of Management and Technology, Kolkata, India. Today, I will discuss about vectors and matrices in Matlab. How we can append a row or column to a matrix. A column can be appended by using the following command: A equal to AX. It will append the column vector X to the columns of existing matrix A. Similarly, to append a row Y, we have to use the command A equal to A with a semicolon, we will write Y. This will append the row vector to the rows of existing matrix A. How can we delete a row or column of a matrix? Rows and columns of a matrix can be deleted by setting the corresponding row or column vector equal to a null vector, that is a pair of empty square brackets. For example, f equal to 6, 7 with a semicolon 8, 9. It means when we are separating it with a semicolon 8, 9, that means it becomes a 2 cross 2 matrix with the second row as 8 and 9. The column 6 and 8 is the first column, 7 and 9 is the second column. Now the command f1 with a comma, a colon operator equal to null gives f equal to 8, 9. What does it mean? It means that the first row is now emptied. Similarly, if G equal to 6, 7, 1 with a semicolon 8, 9, 2, then it becomes a 3 cross 2 matrix, and the command G equal to colon comma 1 to 2 equal to null, it will give G equal to 1, 2. What does it mean? It means that all the columns from 1 to 2 are specified as null. How can we concatenate matrices? It is a method of combining or connecting or joining small matrices together to make larger or bigger matrices. The pair of square brackets is the concatenation operator. For example, A equal to 1, 2, semicolon 3, 4, B equal to A plus 1, semicolon, A plus 24, A plus 10. It will give you a 4 cross 4 matrix. And you can see the matrix B for the first row, first two elements is 1, 2, and the second row, first two elements is 3, 4. That means it is A. Then for the B, first row, third, fourth element is 2, 3, and the second row, third, fourth element is 4, 5, which means it is basically A plus 1. Similarly, you can understand what is A plus 24 and which one is A plus 10. We want to generate some special matrices. Zeros, ones, I. Zeros PQ, it will return a rectangular matrix P cross Q of all zeros. Similarly, ones PQ will return a rectangular matrix P cross Q of all ones. I PQ, it will return a rectangular matrix P cross Q with ones on the main diagonal and zeros elsewhere. The three commands discussed above with a single argument P produces corresponding square matrices of dimension P cross P. We can think of some more special matrices like rand n. It will generate a matrix A with random entries chosen from a uniform distribution of the interval 0 to 1. Rand mn. Similarly, it generates a m cross n matrix of random numbers. Rand smn. It is similar to rand mn and generates a matrix m cross n, but random entries are now chosen within the interval -1 to +1. And rand n, similarly, it will generate a square matrix of dimension n cross n in the interval -1 to +1. Important function is Vander V. What is Vander? Vander means Vander Monod matrix, we all know. V, whose columns are powers of the vector V. Let V a given vector 1, 2, 3. So Vander V gives 1, 1, 1, 2, 2, 4, 2, 1, 9, 3, 1. You can understand that it is V to the power n minus 1, V to the power n minus 2, Like this it goes on. Diag V, if V is a row or column vector with n elements, it returns a diagonal matrix with vector V on the diagonal. Syntax is diag Vk. This returns a square matrix A of order n plus absolute k with the elements of vector V on the kth diagonal. We want to discuss some useful commands related to matrices. Let matrix A equal to 1 2 semicolon 0 4, that means it's a 2 cross 2 matrix. Det A, it will return the determinant of the square matrix A with result 4. Rank A, it returns the rank of the rectangular matrix A with result 2. Similarly, trace A returns the sum of the diagonal elements of a rectangular matrix A with result 5. Inv A, inverse of the matrix, that is A inverse. Norm A, it returns the Euclidean normal. Similarly, A transpose or A dashed returns the transpose of the specified matrix A. We are accustomed with normal division, but here we want to show left division. X equal to A left division B. It returns the solution of vector X of a linear system described by a set of linear algebraic equation Ax equal to B. So if A equal to 1 2 0 4, B equal to 1 semicolon 2, then X equal to A left division B will give X equal to 0 and 0.5. That is X1 equal to 0 and X2 equal to 0.5. Similarly, poly A, it returns the coefficients of the characteristic polynomial P of the square matrix A. Syntax is P equal to poly A. Eigen value of a matrix A is obtained by eig A. Vx equal to eig A returns the eigenvector V and the eigenvalues shown on the main diagonal of the matrix X. The eigenvectors are V1 and V2 and the eigenvalues are shown on the main diagonal of matrix X. X equal to eig SB returns 6 largest magnitude eigenvalues of matrix B. Ortho A B orthogonalizes the rectangular matrix B. Find A, it returns the row and column indices of the non-zero entries in the matrix A. Ij equal to find A. In this function, I gives the vector of row indices of non-zero entries of A and j gives the vector of the column indices of the non-zero entries of A. Sort E, it sorts each column of the matrix E in the ascending order. Matrix and array operations. Now matrix operations follow the rules of linear algebra in Matlab. It follows the following arithmetic operations to be carried out on matrices. A plus B if A and B are of same size. A minus B, similarly if A and B are of same size. A multiplied by B is valid if number of columns of A is equal to number of rows. A divide B similarly is valid only when the following is confirmed. A to the power 2, that means A square, is valid if A is squared and it equals A into A. A to the power P effectively multiplies matrix itself P minus 1 times. If a matrix equation is given by Ax equal to B, then the command x equal to A left division B will give x equal to A inverse B. Some arithmetic operations on arrays are done on element by element basis. This is a very common mistake when we are dealing with Matlab multiplication, division or exponentiation, because everything in Matlab is dealt in matrix notation. So if we want any matrix elements to be multiplied by some other matrix elements, then we have to use dot star, otherwise it will be a matrix multiplication. Similarly for division, exponentiation, everything. Some relational operations are shown here: less than equal to, greater than or equal to, not equal to, and we have to keep in mind that it is relational operation. So it will be either true indicated by 1 or false indicated by 0. Logical operators are shown: and, or, logical complement, that is not operation, XOR operation, that is logical exclusive OR. Similarly, in the previous case, if the condition is true, result will be 1. If it is false, result will be 0. If the Matlab functions receive an array of input values, then the function is performed for each element of the array separately, that is element by element basis. For example, let x equal to 0, pi by 2, pi. So statement y equal to sin x and z equal to cos x will compute sine and cosine individually for each of the elements of x. What are structures? Structures are collections of different kinds of data organized by named fields. Similar to those available in other programming languages like C, Matlab commands like size and ripmat work with structure arrays just as they work with normal arrays. How to build a structure array? A simple one by one structure array can be built by assigning data to individual fields that are accessed by structure name post fixed by dot and then followed by field name. As for example, we are generating a structure student. So student name, how we will write student dot name equal to Anushka Shah. Student dot roll number equal to 10. Student dot marks equal to the marks we want to specify, like 72, 84, 59 with semicolon, 76, 89, 78 with semicolon, 72, 90, 98. Now, by typing the name of the structure student at the command prompt, we get student equal to name Anushka Shah, roll number 10 and marks, that is shown how many marks are there, 3 cross 3 and double format. To increase the size of the structure array, define the second structure element of the array using the following index values. Student2.name equal to Riya Mukherjee. Student2.roll number equal to 11. Student2.marks equal to the marks. Now by typing the name of the structure student at the command prompt, we get what is the structure of that particular structure. The structure array can be further expanded. It is not mandatory to assign data to all fields in structure. The unassigned fields are represented by empty matrices. For example, expanding student structure array as student3.name equal to Arindam Chaudhary. It expands the student structure array to 1 by 3, but the student3.roll number and student3.marks fields are empty. So like this, we can go on increasingly. And a field may also be added in the structure array by adding that field to a single structure. For example, student3.branch. It is electronic. Similarly, a field may be removed from all structures in the array by using rm field command as student equal to rm field student branch name. A function struct can be used to define or build a structure array. Student equal to struct field 1 value 1 field 2 value 2. This is the syntax. To define the second structure, index values may be used. Student 2 struct field 1 value 1 field 2 value 2, like this. How to obtain data from structure? A field of a particular structure can be accessed by appending a period to the structure name followed by the field name. First underscore student name equal to student1 dot name. If part of the data field in a field is to be accessed, proper index may be used, like part marks equal to student2 dot marks 2, 2. That means that particular mark will be accessed. What is a cell array? Cell array is an array of cells. Each cell stores an array. The elements of an array in a cell are all of the same type, but two different cells may have different types of elements. For example, one cell of a cell array might contain array of numeric values. Another cell may contain an array of text strings. And a third cell may store an array of complex values. So we can see that there is no limitation what the cells can store. Now how can we create cell arrays? The cell function creates empty cell arrays of the specified size. To create an empty cell array sample of size 2 by 2, the following command is used. Sample equal to cell 2, 2. Cell array can then be built by assigning data to the individual cells one cell at a time. Data can be assigned in two ways, cell indexing or content indexing. What is cell indexing? Cell index values are enclosed in parentheses using standard array notation. Cell contents are mentioned on the right of the assigned statement in curly braces. This you have to maintain. For example, a 2 by 2 cell array sample is built as sample 1, 1, that is the first element, equal to the numbers within third bracket within curly braces. Sample 1, 2, the name within curly braces. Sample 2, 1, some other thing within third bracket within curly braces. And sample 2, 2 within third bracket within curly braces. So what is content indexing? Here the braces are used in reverse manner. Cell indices are put in curly braces while the cell contents are mentioned on the right side of the assigned statement as done for standard arrays. For example, a 2 by 2 cell array sample is built as sample within curly braces 1, 1 and simple that value we have to assign. Similarly, sample 1, 2, sample 2, 1, sample 2, 2. The two forms that can be used interchangeably. To display the full cell contents, use the cell disk function. Cell disk within bracket the name of the cell. And for a high-level graphical display of cell architecture, use cell plot. The syntax is shown. Finally, I want to thank you for patiently hearing my lecture.